When you hear civil engineering, your mind probably jumps straight to bridges, roads, maybe some big buildings. And yeah, you're not wrong. But today, that field is about so much more. It's literally about writing the blueprint for our future, and things are moving at an incredible pace. So let's jump right in. Look around. From our cities to our climate, the basic systems that keep our world running are under a ton of pressure. Seriously, the old ways of doing things, of building and maintaining everything, they're just not going to cut it anymore. We need some radical new solutions, and honestly, we need them like yesterday. So what's really driving this push for change? Well, it pretty much boils down to three massive interconnected forces. First, we've got rapid urbanization. More people are moving into cities than at any point in history. Second, a changing climate that is basically screaming for smarter, tougher infrastructure. And third, just an absolute explosion of new technology that's changing what we even thought was possible. These are the big challenges we're going to unpack. And that right there brings us to the big question. Who's on the front lines, tackling these massive problems head on? Well, the answer is civil engineers. They're the ones becoming the architects of our response, using all this incredible science and creativity to design the world of tomorrow. Okay, so let's start with that first one, urbanization. Billions of us are living in cities. And for those cities to work for everybody, they need to get a whole lot smarter. This is where engineering is stepping in to create these truly intelligent environments. The central idea here is the smart city. And no, this isn't some far-off science fiction. It's about weaving a kind of digital nervous system into our cities. A whole network of sensors and AI that are constantly collecting data to make everything run better. Just imagine a city that can see a traffic jam forming and reroute cars before it happens, or one that can shift power during an outage, or even just tell you exactly where the nearest empty parking spot is. All of it happening in real time. You can really see this shift when you look at how we get around. I mean, yesterday was all about passive infrastructure, just dumb roads that inevitably led to gridlock. But tomorrow is all about flow. Engineers are designing systems where AI is optimizing traffic lights every single second. They're building dedicated lanes for self-driving cars. And get this, they're even developing smart pavements that could charge your electric car as you drive on them. Wild, right? And the tech that's making all of this a reality is just as futuristic. We're talking about artificial intelligence that can predict when a bridge will need repairs long before it becomes a problem. We've got drones flying over construction sites, giving us a perfect picture of progress. Supply chains are becoming totally transparent and secure, thanks to blockchain. And we even have robots on site, building structures faster and way more safely than ever before. Okay, so from smart cities, let's pivot to that second massive force, our changing climate. This is a big one, and it's not just about building green anymore. It's about engineering a world that can actually withstand and adapt to a whole new set of environmental realities. This quote from Robert Swan just hits the nail on the head, doesn't it? Waiting around for someone else to be the hero, that's not an option. Civil engineers are taking this responsibility on directly, and they're doing it by fundamentally rethinking the very materials we use and the structures we build. For example, let's take one of the most common building materials on Earth, concrete. It has a huge carbon problem. Its production creates massive amounts of CO2. Now, the traditional solution might be, well, let's just use less of it. But the engineering solution is way cooler. It's to invent a brand new kind of concrete that actually absorbs carbon dioxide from the atmosphere as it hardens. It's not just carbon neutral, it's carbon negative. And that's just one tool in this incredible new green toolkit. Engineers are pioneering the use of recycled materials in brand new buildings. They're looking to nature for inspiration, a field called biomimicry, to design structures with amazing efficiency. And they're totally revolutionizing how we manage our water with advanced treatment systems and smart meters to conserve every last drop. Building a resilient planet also means being ready for the worst-case scenario. And this chart shows just how direct the response is. For the threat of earthquakes, engineers are now designing buildings that not only survive a quake, but remain usable afterward. For floods, they're creating these incredible adaptable barriers that can rise to the challenge. And for wildfires, they're inventing totally new materials that are intensely fire-resistant. It's a direct counter for every threat. All right, this brings us to our final section, and it's where things get really cool. We're diving into the foundational tech, the new matter and methods that make everything else we've talked about possible. We've seen what engineers are building. Now, let's look at the incredible new stuff they're using to build it. Let me just ask you a question. What if our infrastructure wasn't so
fragile. I mean, what if a tiny crack in a bridge or a road could just fix itself? It sounds like something out of a movie, I know, but it's actually becoming a reality.
It's a whole new class of self-healing materials. The basic idea is that you embed these materials with tiny little capsules. When a crack forms, the capsules burst open, releasing a resin that fills the gap and hardens. Think about that. This could dramatically extend the life of our roads, our bridges, everything, saving literally trillions of dollars and making our world so much safer. The implications are just huge. And the innovation just keeps on coming. We're talking about concrete mixed with graphene that's so strong it's almost hard to believe. We're talking about nanocoatings, these microscopic layers that can stop rust and corrosion before it even starts. There are even smart, adaptive materials that allow entire structures to actively respond and change based on their environment. So, how are we putting all these amazing new materials to use? Well, one of the most exciting ways is 3D printing, but on a massive scale. It's a pretty straightforward process, actually. First, you create a digital blueprint. Then, you bring in these giant robotic construction arms. They extrude the specialized material layer by painstaking layer to create modules. And finally, you assemble those modules into the finished building. It's faster, it creates way less waste, and it opens the door to architectural designs we could only dream of before. So let's pull all these threads together now. We've looked at how engineering is tackling urbanization, how it's confronting climate change, and the explosive new technologies it's using. What does this grand vision really look like when you put all the pieces in place? If there's one thing to take away from all of this, it's this. The future is not something that just happens to us. It's being actively designed. It's being constructed right now, all around us. It is being engineered with purpose, using these incredible new tools to solve our absolute biggest challenges. And that really just leaves us with one last fascinating question to chew on. What will our world actually feel like to live in when these blueprints become a reality? A world with roads that heal themselves, buildings that literally eat carbon out of the air, and cities that intelligently adapt to our every need. These aren't just ideas on a screen anymore. This is the reality that's being built, piece by piece. And that, right there, is a future worth getting really, really excited about.